Okay, finishing up this conditional statement thing. We've got an example here of the statement, I will ask her out on a date if she seems interested. That's the statement I'm making. The first question is to write it as a conditional statement in standard form, then write the converse, inverse, and contrapositive. And then if the original conditional statement is true, do you know any for sure that any of the others are true? Okay, so I'm going to do that. Why don't you can do this as a nice practice and see if you can get these right. So try them out right now. So pause the video. You're pausing, right? Okay. Okay, so here's the ask her out on a date one. So if she seems interested, then I will ask her out. That's a statement in standard form. If something, then something. So then the converse, remember the converse, I switch the order. So converse is, if I ask her out, then she'll seem interested. Sounds kind of weird when you say that, but that one's kind of like, okay, maybe. I'm not sure about that. The inverse, remember, that's the switching them and making them both not true. So if she isn't interested, then I won't ask her out. And that one sounds a little bit more like plausible. That one's like, maybe, it depends. Sometimes people just go for it anyway and ask somebody out anyway. I was not one of those people, but some people were like that, I'm sure. And so that one's kind of like, I'm not sure. But then the contrapositive is, if I didn't ask her out, then she didn't seem interested. And if the original statement is true, then the contrapositive there has to be true. And that's something that is general rule. As if the original statement is true, you don't know about the converse and the inverse. It's like, maybe. But if the original statement is true, you definitely know that the contrapositive is true. So converse and inverse, sometimes yes, sometimes no. Contrapositive is always matches the original statement. Original statement true, contra's true. Original statement false. The contrapositive is false also. Okay, biconditional then. A biconditional statement is one where the original and the converse are both true. So if you know both those things are true, the original and when you switch them, that is true, then that's called a biconditional statement. So example, if you have math scheduled in A504 this year, then you have Mr. Ellinger for math. And that's a true statement. That's a true conditional statement in standard form, right? If you have math, if you have a math class and it's in A504, it must be me because there's no other math teachers in here. And so that's the original, but then we could switch it and we could say, if you have Mr. Ellinger, this is the converse. If you have Mr. Ellinger, then you're in 504, in A504, which is also true. So a statement where the original and the converse are both true, that's called a biconditional statement. And the standard way to write biconditional is with the phrase, if and only if. So for example, a polygon is a pentagon if and only if it has 5 sides. Meaning, if it's a pentagon, then it has 5 sides. If it has 5 sides, then it's a pentagon. Both those are true. And biconditionals are used really often in definitions. We say, especially with math definitions, if 2 lines are in the same plane and they never intersect, then those lines are parallel. But it's like, oh yeah, and if 2 lines are parallel, then they never intersect, then all those things are true. And so that's because that's the definition of what parallel means. So you see it very often in definitions that things are biconditionally true. If this, then this, and the other way around. Another one that you might not know is Pythagorean Theorem. If it's a right triangle, then a squared plus b squared equals c squared. If a squared plus b squared equals c squared in a triangle, then it's a right triangle. So you might not have known that it worked backwards too, but you knew it that way, but maybe not that way. And it turns out to be true, and so that's a biconditional statement. So that's a right triangle. A squared plus b squared equals c squared if and only if the figure is a right triangle. That's the easiest way to say it. Yeah. And so that's the end. Oh, and there was one thing I was going to mention. People write this by symbolically. They write it with P double arrow Q. Say P implies Q and Q implies P. Either way. All right, that's the 2.1 stuff. And so if you took these notes and you noted any questions and you reflect on your learning and have a moment with that, then you're good. No additional stuff in 2.1.